Okay, here's the problem-solving video for Learning Extension 2.14. Says find V0. We're going to be utilizing the problem-solving strategy on page 49. Step 1 says systematically reduce the resistive network so that the resistance seen by the source is seen by a single resistor. So if we start, we'll start over on this end and work back toward our source. If we note here, these two resistors are connected in series. That's because this is zero current, so the same current that flows here, we'll just call it I1, is also the current I1. So let's start by combining those two resistors in series, and let's redraw our circuit, okay, to account for that. Okay, so once we make that combination, we have this. Now V0 is no longer in our circuit because we combined the 40 and the 20 in series to give 60. V0 disappeared, so we're going to have to come back to this circuit to be able to calculate V0. Now these two resistors are in parallel, so let's combine those, and those two resistors, our circuit redrawn would look like the following. And back on this diagram, we have 30K times 60K over 30K plus 60K. That'll give us 20 kiloohms. So then this is also 20 kiloohms. Okay, so now these two resistors are in series, so if we do as a problem-solving strategy instructs us, our circuit can be reduced down to the following: 12 volts, 40 kiloohms. Okay, now step 2 says determine the source current. Okay, so we'll call that current IS. Okay, and IS is 12 divided by 40K, which is 0.3 milliamps. So now we've completed step 1 and step 2, and now we're going to work back toward our original circuit, expanding it. So in this circuit, this is 0.3 milliamps. And we're going to use things like voltage division and current division as we proceed back through our network. So if we go back to this circuit, okay, this is also 0.3 milliamps. And another thing that we can do, if we look at this circuit, for instance, we know that that voltage is 6 volts. Okay, and we can get that just from Ohm's law. We have 20K times 0.3 milliamps. So if we look at this circuit, then this voltage is 6 volts. Okay, and then we can use to calculate the current. For instance, we know the current through here is 0.1 milliamp. The current through here is 0.2 milliamps. We could have come to the same conclusion using current division. And then back in our original circuit here, this is the 0.1 milliamps. So then I1 is 0.1 milliamp. So V0 then is 20K times 1 milliamps. So then V0 is 2 volts.